In the previous lecture, we architected an application which made HTTP calls and handled all asynchronous work by using promises. In this lecture, we are going to implement exactly the same application, but by using observables instead. Now, our goal in this lecture is not just to replace promises with observables, but instead go deeper and implement most of our functionality with an observable chain. Now, working with observables does require a different way of thinking about programming, and it's my hope that after this lecture you will have a much better idea of how to solve similar problems with RxJS and observables. Now, just a really important note that we still need to use the cause plugin that we installed in the previous lecture. Or if you're using another cause workaround, you still need to use that workaround. We're going to cover a solution where you don't need to use a cause workaround in the next lecture. Now, on the screen right now, you see, well, exactly where we left off in our promise example in the previous lecture. In this promise example, we stored the return results on the service itself in the results property. But in this observable example, we are instead going to make the search function return an observable which the app component is going to subscribe to. Now, to use the observable class in our Angular code, we need to import it. So I'm going to import observable from RxJS. And since our search function is now going to return something, I'm going to give it a return type. This is just a feature of TypeScript where you can specify the exact return types of a search function, of any function, sorry. So I'm saying the return type is observable, and then I'm passing in an array of search items. What this means is that the search function is going to return an observable where each item in the observable is an array of search items. Well, that's our intention at least. We need to adjust our search function to make it a reality. Now, one kind of initial attempt to get this working might actually just be this. We remove the promise code, and since HTTP GET returns an observable, specifically an observable of response types, we might as well just try returning this instead. But it kind of has a couple of key problems, one of which is that it's not returning an observable which emits search items, it's returning an observable which emits HTTP responses. And related to the fact that it's not emitting search items, we also need some code in here which converts the raw JSON to our search item domain model. Basically, we still need to convert the response from the HTTP request to an array of search items. And we can do that with our observable by running a map operation where we convert each response to an array of search items. Now, this map function here is actually an observable operator. Don't be confused from the other map function that we use, which was an array function. This is an observable operator because it's acting on the observable that's returned from HTTP GET. So like all observable operators, we need to include it in our imports. So I'm going to add it to the top, but actually we don't need the toPromise operator anymore, so let's just replace it with map. Now let's continue with our function here. So map acts on the observable chain. So res here is actually an entire response object from the HTTP request. So we need to convert that entire response object into an array of search items and return an entire array of search items. So we might type something like this. So this is going to convert the response that we get on the HTTP request, and we're just extracting the results part of the response and converting it to just that result. But we don't want that. We actually want to convert this result into an array of search items. So we can just use the very similar function to what we used before. So just like the promise example, we're looping over the results array. We're converting it into an array of search items. And then we're just returning that array of search items on our map operator. So this is converting the response into an array of search items. And the end result is that our code converts the observable response that gets returned from the HTTP GET request to an observable of arrays of search items, which then returns to the caller. Now the caller in our case is the app component, so we need to change that to work with observables as well. Now, one way to use this observable in our app component would be to just subscribe to it and store the results locally on the component. So I create a private property called result, which is going to hold an array of search items. And then in our search function, it now returns an observable. And what do we do with observables? We subscribe to them. Now this observable returns some data. Now each item that it emits is an array of search items. So we want to do two things. Firstly, we still want to set loading is equal to false. That's still the case here. And secondly, we store the data that gets emitted on the observable in our results property. And we also now need to loop over our local results property instead of our iTunes results property. And now if we rerun this application, and now if I search for love, it's functioning just like before, but this time we're using observables instead of promises. Now, this is a really good start, but we're not really using observables to their full extent. For one thing, we are subscribing to the observable and storing the results locally on the component. We can skip all of that by just using the async pipe in our template. So we change our results property from just being an array of search items to an observable which emits an array of search items. Then there's no need to subscribe to our observable. All we need to do is store the observable that gets returned from iTunes.search into our own results property. And finally, to make this work, we need to use the async pipe in our ng for loop. If you remember, the async pipe automatically subscribes to the observable that gets passed into it. And at the same time, when the app component is deleted from the view, it will automatically unsubscribe from the observable. So now if we rerun the application, search for love again, and it's working, well, pretty well. It's working okay. We're still only showing the loading indicator. We're not disappearing the loading indicator. I'll show you a mechanism of solving that later on. But essentially, we're now using observables just much better. We're not subscribing to the observable. We're not storing some intermediate data on our app component. We're just subscribing to it and rendering it on the screen by using the async pipe. Okay, let's see how much more we can do with observables. Pressing a search button every time we want to make a search is quite old. We don't need to do that anymore. Let's change our application so it uses a reactive form and performs a search as we type into the search field. Now, we've covered reactive forms before, so I'm just going to speed through this section. Now, the first thing I'm going to do is add a search field property to our component. Search field property is of type form control. It will hold a form control later on. And then I'm going to initialize this search field, but I'm going to do this on an ng-on-init function. So I initialize search field with a new form control, and then I want to link this form control to our input field. So I'm going to use the form control directive to link it. So I'm going to just replace our template reference variable there. And we also actually don't need the button anymore, so I'm just going to delete that. So now this input field here is linked directly to the search field on our app component. And if you remember from the reactive forms section, the search field or form control exposes an observable via the value changes property. And we want to add a chain of functions on this value changes observable. Now I'm just going to use very similar code to what we used in the section on reactive forms. So if you're confused as to what I'm about to add, please go back and review that section. So on the value changes observable, I add an operator of debounce time and distinct until changed. And then I also have to subscribe to this chain to make it hot. And also, since I've added these two operators, or I'm using these two observable operators, we need to import them at the top of our file. Just like that. And finally, to support all of these new form-based classes, we need to import some data from the Angular Forms module. So we're importing reactive forms module, form control, and forms module. And both of these modules we also need to add to our ng module imports. Now we need these modules because we're using reactive forms. Okay, now we have an observable on the app component here. And this observable emits a search term every time we want to perform a search. We also have the search service, which returns an observable via the search function with the results of performing a search. How do we link these two observables together? Now what's going on, I'm just going to put some comments and code in here. The value changes observable is of type observable string. It's an observable which emits a string. Now the search function from our search service, that is of type observable search item, an observable which emits an array of search items. Through a chain of operators, we want to convert an observable that returns a string into an observable which returns an array of search items. Now to start with, let's use the map operator. So here we're calling the search service every time we emit something from our search field. Now I'm just going to print this, whatever is at the end of our chain, to the logs. So now if I run the application, and in fact I want to open up the console as well so we can see stuff getting logged. Now let me rerun the application. Everything's fine. Let me clear the console and let me type in love. Now, instead of seeing an array of search items printed out, we see something that looks like an observable. Now what's happening here is that the iTunes search function, this isn't returning an array of search items, it's returning an observable which returns an array, which emits an array of search items. So in our map operator, we're not converting an observable that emits a string into an observable which emits an array of search items. In fact, we've done this. Through a chain of operators, our observable is now emitting another observable which itself is emitting search items. So when we subscribe, we're actually getting the observable returned in our subscribe callback here, and that's what we're printing out to the console. So one workaround would be to just try and do two subscribes. So in our subscribe function here, so value is another observable. In fact, let me call it observable. So when we subscribe, we're getting past an observable So we have to call subscribe on the second observable, and only then will we get some data returned that looks like an array of search items. So now if I rerun the application, clear the console, type in love, and in the console we're now seeing something which looks like an array of search items, which is an array of search items. But this is a really common problem when using observables, so there is actually a better way. We can use another operator called switch. Now switch expects a stream of observables, and when it gets an observable pushed onto its input stream, it unsubscribes from any previous observables, subscribes to the new observable, and then emits any values from that observable onto its output stream. To put it another way, it converts an observable which emits an observable which emits an array of search items into an observable which emits search items. Okay? Now I know that hasn't made any sense at all, so I've created an animation which should hopefully explain what switch is doing. Now the yellow bar at the top represents time. We're going to go left to right. As we go left to right, we're going to be experiencing time. We have the debounce operator at the top. We have the map operator in the middle, and we have the switch operator at the bottom. So at this point, the user searches for the text moo. This gets pushed out by this gets emitted, by the debounce operator. Then our map operator gets the search term moo, calls our service, which returns an observable. That observable is emitted by the map operator, and so the switch operator then subscribes to the observable, and then sometime later that observable emits a response. Because the switch operator had subscribed to that observable, it then gets a copy of that response, and it then emits that response to its output stream. And then sometime later on, the user searches for the search term foo. This gets output by the debounce operator. And this gets input into the map operator, which then calls a service, which then returns a new observable. The switch operator then unsubscribes from the old observable. It then subscribes to the new observable. And again, sometime later, the HTTP request returns and the observable emits a response. Because the switch operator had subscribed to that observable, it then gets a copy of the response and emits that on its output stream. So that might seem a little bit complicated, and it is a little bit complicated. But trust me, understanding switch will help you understand observables and reactive programming as a whole. So if you didn't quite understand this, just rewind this video and just watch it again. And so to use switch, all we need to do is add switch to our observable chain. We don't need the second subscribe anymore. And because we're using a switch operator, we need to include it in our imports at the top. And now if we rerun our application, clear the console, I'm going to type love again. And here we go, we're going to see search terms printed out on the bottom. And then if I search for moo, we see a second set of search items printed out on the bottom. Okay, so using switch with map is such a common occurrence that there is a combined operator called switch map, which we can just use like this. And again, we just need to make sure we include switch map in our list of operators. So now if we go back into our code, through this chain we've now converted an observable that emits a string into an observable which emits an array of search items. So now we can actually just assign this observable chain to our local results property, which we've said already holds an observable which emits an array of search items. And since we're using the async pipe in our template, we also don't need to subscribe to our observable chain anymore. And now if I rerun the application, we should see some results rendered to the screen. Like so. Now, the final thing we need to do is to add our loading indicator back to the chain. We have our loading Boolean, and we need to set it to true when we've initialized the search and set it to false when the search has completed. Now, to do this, we can use something called the do operator. So how I want to use do is just after the distinct until changed operator. We call do, and we pass to do a function which will manipulate some local state property. So we want to set this.loading is equal to true. And then after switch map completes, I want to set this.loading to false. And again, to use do, it's another observable operator, so we need to import it as well. Let's go to the top. Add do in. So what do does is it allows us to create something called a side effect in our application. So basically it lets us do things outside of just manipulating items via streams. So do isn't doing something with the input stream. It's just letting us change variables on our component. Now it should be used infrequently, but this is a perfect example. Setting some state on our component depending on where we are in the processing chain, in our observable processing chain. So at this point in our chain, I want to set the loading to true. At this point in our chain, I want to set the loading to false. And so now if I rerun the application, if I search for love, we see the loading indicator, and we also see the loading indicator disappear. Again, if I search for moo, we see the loading indicator, and then it disappears when the results are returned. That's it. We've converted our solution that uses promises into a solution that uses a lot of observables. So to summarize, in this lecture, we covered in depth how to use observables when making HTTP requests. The goal of this lecture was to show you how you can evolve your application from one that uses just a little bit of observables to one that uses a lot more. And hopefully you now have a much better idea of how to architect your application using observables. We could go even further. For instance, the loading property could be its own observable. How far and how deep to go is up to you and how comfortable you feel with observables and how well they match your use case. Observables can be really powerful, but at other times they can be a big hindrance with little benefit. In Angular, you can use as much or as little reactive programming as you want. It doesn't prescribe one way or the other. So far, we've not dealt with the issue of cores, and we cheated in creating these apps by installing a plugin to Chrome which circumnavigates all of the cores security issues. In the next lecture, we're going to cover how to use JSON-P to solve cores issues if your API supports JSON-P, that is, and how to implement JSON-P requests in Angular.